Hello everybody, welcome back. Today we're looking at 7.7, solving quadratic equations by using the quadratic formula. So this is going to be algebraic. A lot of the things we've done so far, we've been able to do it on the graphing technology as well. This one you'll be doing, I guess, strictly through the quadratic formula. However, you can always check, I guess, using the graphing technology. So this is just another way to determine the roots. It's done using the quadratic formula. Like if you can't factor, and if you didn't have a graphing technology used, this is the method you would have to use for sure. And of course, it has to be in the standard form. So once we have our equation ax squared plus bx plus c, we can now solve this question. All right. So just to make sure we have an understanding, the a value, right, is going to be 6. Oh. So the a value is 6. The b value, it's not just 7. You have to take the sign to the immediate left, so it's -7. And c is equal to not 3, -3. Take the sign to the immediate. And those are the letters that are going to go into your quadratic formula. When we get to Pre-Cal 11, we'll do some more of this. For those of you that are going on that pathway of the advanced with the Pre-Cal 11, we'll talk more about this quadratic formula and some of its properties. But for now, we're just going to learn how to use it to solve. So we write down our formula. Once we write down our formula, then we fill in everything we know. B is -7, but it's minus b, so it's -7. And then the b is -7 squared. A is 6. Brackets are important here. C is -3, and A is 6. Okay, so we plug everything in. Now we're going to simplify. So the -7, minus a -7, that's actually just going to be 7. Plus or minus, we do this at the end when we split. I'm going to show you that part. -7 squared is 49. And -4 times 6 is 24, times -3 is 72, so it's plus 72. Okay? And the denominator is 12. Right? 2 times 6. Now we got to take what we have underneath the square root sign. Okay? Add them two numbers together. So when we add those two numbers together, we get 121. And then we're going to take the square root of 121 and we get 11. And that's why the plus or minus is there. Because if you take the square root of 121, you get 11. But -11 squared is also 121. So that's why it's the plus or minus. And that's why we end up with two values for our quadratic. Okay? So now we split it. And one of them you're going to do plus. And I've seen people put x1. And I talked about this earlier on in the two roots. So some people call it x1, and then some people, what they'll do is when they split it, they call one x1 and the other x2. And that's fine. It depends on your text. Just because like some people's argument is you can't have two values for x, which means the same thing. So there are two x values. They are the roots. They are the x-intercepts. You put one with the plus and one with the minus. All right. So we'll do the work on the first one. 7 plus 11 is 18, and we can simplify that. You know me, I'll try to avoid fractions at all costs. That would simplify to 3/2 or 1.5 is fine. Okay, 1.5. And then the other one, the second one, we're going to subtract. So when we subtract, we end up with -4 over 12, which we know simplifies to -1/3. And here's why I prefer this over the decimal. Yeah, it doesn't make a difference, but because this is not exact, it's 0.3, and the 3 will repeat, as you folks are aware. So that's a decimal with the 3 over it. So that's why I like fractions. You can just leave it as a fraction. There's no need for the decimal. All right. So that's how you use the quadratic formula. You just plug the values, substitute the values of a, b, c in. Again, it needs to be in the standard form or general form. So standard form is when it's equal to 0. Again, there's different texts have different examples of what they call standard form. But those are the two x-intercepts essentially, right? The roots. So again, we go to our graphing technology. And if we plug that original equation, remember we have to put y equals in, you got to put it as a function. You get 6x squared minus 7x minus 3. And look at your roots. Decimal 3 repeated, or 1/3, and 1 decimal 5 and 0. So that's the two solutions we ended up with here. So again, we can check it on the graphing technology. I recommend that for sure. And there they are. Okay. Example 2, solve the following using the quadratic formula. Again, we will just work through this one. Same thing, but look at the form. So the first thing obviously we need to do is we got to rearrange this, set it equal to 0, right? So write down the formula. So we're going to subtract 47x from both sides. Subtract 47x. You'll notice where I put it. I put it here in the middle because I like to have ax squared plus bx plus c, right? And when I do that, the 47x minus 47x is eliminated. That's why we did it. And we end up with 0. Of course, like I mentioned before, that's why we did that there. Okay? So that means that we have A is equal to 12, B is equal to negative 47, and C is equal to 45. Okay? Alright, and we'll plug it in the quadratic formula. So there's the quadratic formula. We write it down. And no, you don't have to memorize the quadratic formula. It's certainly not necessary. Okay? So plug everything in. Negative 47 again. So negative 47 plus or minus negative 47 squared. Oh, I lost the squared. Let me fix that. Negative 47 squared. A is 12, I'll put it 12, and C is 45, 45 for C, and A is 12 again. Okay, so I substitute all my values for X, for A, B, and C in, and now I'm going to do my cleaning up. I say clean it up, so let's do the operations. The negative 47 is positive 47, negative 47 squared. 2209, and then negative 4 times 12 times 45. And that gives me negative, 2160. And then the denominator is going to be 24. Okay? So I simplify underneath the square root sign. When I subtract those, I'll get 49, which is a good number. It's not always going to be a perfect square, by the way. It's nice when it happens, but it's not always going to be a perfect square. And if it's not, you just write the decimal down. In pre-cal 11, we'll keep it as an exact value, but we don't need to know that for here today. Okay? And this is where we split into 2. You can call it x1, y1, or not. You can leave it. It doesn't make any difference to me. If you prefer to have x1, x2, it's up to you, or you can just leave it. Okay? Now remember, once we split it, 1 is plus and 1 is minus. That's the whole idea of splitting it, right? Okay? So then we'll do the operation. 47 plus 7 is 54. 47 subtract 7. We'll do them simultaneously at the same time there. Okay? And then we'll simplify these fractions, of course. 54 and 24, they can both be divided by 6. So we end up with 9/4 here. And this one both be divided by 8, so we end up with 5/3. And again, I like to leave them as that. You can change them to a decimal or if you want, but that is more than okay with me. This one, This one's a better decimal because it's terminating. It's 2.25. Unlike the second value, which is non-terminating, but it is repeating. So that is ended up being a 1 decimal, 6 repeated. So we put that little line over the 6, which shows the 6 goes on forever. Okay. Again, we can double check this if you wish. Let's go to our Desmos. We'll plug the original equation in, and that was 12x squared minus 47x plus 45, and decimal 1667. It rounded it, and 2.25. Okay. So you can just do a double check to see if those are your two rules. I recommend that as a check, right? And that's essentially it for using the quadratic formula. I'll do the exact value example for you for those of you that are heading to the pre-cal 11, but those of you in the academic, we will, we're not responsible for this. So, that's it for this video, and in the next video for the pre-class, I'll show you how to do it as an exact value. Alright everybody, thanks for watching, we'll talk again soon.